Hello everyone. So today we are doing the topic of ocean currents. It is an important chapter in the physical geography and the questions are asked both in the prelims examination of UPSC from this chapter and also in the mains examination. So ocean currents is a very important topic in the chapter of oceanography, which is the part of physical geography. So these are some of the questions which were asked in the previous year. Like I have given one example of prelims question. As you can see, the most important fishing grounds of the world are found in the regions where. So this question belongs to the chapter of ocean currents. They are asking about the fishing grounds, and the important fishing grounds are actually created where the warm and the cold oceanic currents meet. So once we complete the chapter of ocean currents, you will be able to answer these type of questions in both prelims and mains examination. You can also see some of the questions from mains examination. They have asked what are the forces that influence ocean currents. So here they are asking about the factors which affects the ocean current and also describe the role in their fishing industry. So as you can see from the prelims question, they have a role in the fishing industry, which was also asked directly in the mains examination. Next question, how ocean currents and water masses differ in their impacts on marine life and coastal environment. Again, marine life will be depending upon fishing industry and also the corals and the different kinds of marine animals and minerals they are asking. So somewhere or the other this chapter becomes important. So what are ocean currents, what are the factors behind creation of the ocean currents, how they influence the marine life, what is the role of the ocean currents in weather or climate or any kind of physical factors of geography we will be discussing here. And if you see the world map and if we mark the ocean currents, so this is how the ocean currents look like. Okay, so the most important ocean currents are actually marked on this world map, and for some examples you can see that Kuroshio current is there in the Pacific Ocean, equatorial current is also in the Indian Ocean, Atlantic Ocean, and again in the Pacific Ocean. You can see a very important Gulf Stream on the eastern coast of America. Then you have this current coming down which is known as Canary current on the western coast of the Europe. So these are some of the currents. So first of all, we will discuss that why these ocean currents are there on these oceans. Okay, so let us begin with the definition. So what are ocean currents? So as it is written here that ocean currents are continuous, predictable, directional movement of seawater. So on the ocean water, they are the continuous flow. They are predictable in nature and they have a particular direction in which they move. They are the massive movement of ocean water. So you can say they are like a river flow in the ocean itself. So they are that huge. Okay, we will be discussing about their parameters, their hugeness also. So ocean current moves in two direction, either horizontally or vertically. Okay, so horizontally is the main ocean currents we are talking about here, and vertically the ocean currents are called actually deep water currents. So these deep water currents actually move vertically, and the ocean currents are those which move horizontally and also on the surface or the subsurface, which are actually called the ocean currents. Okay, so if we see, if this is the ocean here, so the surface water which is moving in any direction, so this surface water is actually 10%, around 10% of the whole ocean water. So this is a very big water mass which is actually moving in a particular direction, and the direction also has some reasons. So if a ocean water is moving towards west or moving towards east, it has a particular reason for that which we will be discussing here. Okay, so around 10% of the surface water is moving in a particular direction, and this 10% of a surface water is actually like a river flow because it has a permanent kind of movement, and almost it doesn't change its direction. The direction is very permanent in nature, but in some ocean currents you will also see direction change. We will also discuss that. Okay, so sometimes this ocean subsurface water actually subsides and they actually go deep down because the density increases. So while these ocean currents, while this subsurface ocean water gets cold and the density actually increases, so sometimes this ocean water goes down and it piles up here. So when it piles up here, it can move in any direction depending upon the topographical features of the deep down ocean, or depending upon the movement of the water for a particular reason. So when they move in those areas where there is a vacuum. And if a particular current is moving from this area, so there is a vacuum created, and this vacuum is filled by this kind of ocean current, which is called deep water current. So deep water current actually is the result of down dwelling or upwelling. Okay, and as soon as the water flows on the surface area, this surface area is called the horizontal current, which is actually the ocean current which we are talking about. So let us now discuss about the factors affecting the ocean current. They are actually the factors which are responsible for the creation of ocean current. So the creation is not done by a particular factor, but a mixture of some too many factors actually create the ocean current, in which the first factor we are talking about is the temperature. So temperature is actually gained by the solar radiation which we are getting from the sun. So if we are talking about the ocean water and the solar radiation, so say, through this solar radiation, the surface water gets warm in the equatorial and the tropical regions. So as we know that the tropical regions, the torrid regions, get the surplus heat from the solar radiation because of the tilt of the earth's axis, and that is why water near the equatorial region, the subsurface water, becomes too much warm, and as it becomes warm, it expands. As we all know that when a particular product, when a particular thing is heated, it expands, and the molecules actually expands, and that is why it gains a somewhat height of 8 centimeter in the equatorial region. And because it is expanding, it is actually starts moving. Why is it moving? So it is moving on the force of the winds. So we have some permanent winds which actually help this expanded water to move at a particular direction. So they will move in that direction only in which the wind is blowing. So the expansive nature of the water is created by the temperature and solar radiation, and further these winds are helping the expanded water to move from one place to another. So as it moves from one place to another, a vacuum is created in this part, and the cold water actually upwells at this part, and when it is upwelled or upwelling is happening, the nutrient rich water from the deep down water is coming up, which brings fishes also here. So upwelling portion will be also seeing fishes. So these creates good fishing grounds, because upwelling brings nutrients also above the surface. So that is how the ocean currents are created. As you can see in this diagram, that deep, colder, nutrient rich waters are moving up, and with this nutrient moves also up the fishes, and that is how the fishing ground is created at the upwelling zone. Another factor which is actually creating the water to move is salinity. See, salinity is also defining the density here. In case of ocean water, salinity also defines density. How? See, for example, if this is a column of water, say we can say 1 liter water is here and some 35 grams of salt is here in the equatorial region, and in the equatorial region the evaporation is too much because the temperature is in the higher side, and the surplus heat creates evaporation in the equatorial region. So as the water gets evaporated, the water quantity becomes less, it decreases, but the salt amount is actually constant, so that makes the water saline. But at the same time, with evaporation comes the clouds and condensation, and happens the precipitation, which actually balances here. The salinity of the equatorial water is balancing. But when we talk about the higher latitudes, so in the higher latitudes of the world, the temperature is in surplus. There is not surplus temperature, and the temperature is on the lower side. So with this lower side temperature, the water becomes more saline because the water is cooler here. Okay, so the density actually works when you talk about the salinity feature in the ocean water. So if the water is cooler, if the water is denser, then actually down dwelling will be happening, the water will be residing down deeper. And if the water is actually more saline, it will go down. But if the water is not too much saline, and if the balance is maintained, the upwelling will be happening. So this is how salinity is working in the factors which affects the ocean currents. So next, which I told you, is the winds. So winds which are actually working on the ocean currents are two types of winds. So first are the permanent winds, or which we can call as the primary winds also. So permanent winds actually blow throughout the year in a permanent direction. Okay, and second one is the seasonal winds. Like example of the seasonal wind is monsoon winds. So monsoon winds change their direction with the change in seasons. So as the season changes, the monsoon winds will be changing the direction. So when the winds change the direction, the ocean currents will also change their direction, because what the winds are doing is they are giving movement to the surface water. So they are giving movement to the surface water, and that is how the ocean currents are getting their movement. So if the winds change their direction, the ocean currents will also change their direction. So with this diagram, you can see that we have the prevailing westerlies in the mid latitudes. Okay, around 35 degree to 45 degree north south latitude, we have the prevailing westerlies, and then we have the trade winds in the lower latitudes around 23 degree to 0 degree equatorial region. And then we have polar easterlies, which are again going from east to west in the very high latitudes of around 65 to 90 degree latitude. So as you see the direction of the wind, same will be the direction of the ocean currents. Okay, so we can see the same feature here. See, in the mid latitudes, in the influence of the westerlies, the currents are going on the side of eastern side. Okay, so they are actually flowing from west to east. Again, if you can see on the higher latitudes, they are in the influence of polar easterlies blowing from east to west. And if you see the equatorial region, they are again blowing from east to west. So same direction you can see here on the trade winds map also. So what is the work of the wind in the ocean current factor is winds are giving the movement. They are actually deciding the direction on which these ocean currents, on which this piled up water, the subsurface water will be moving. So winds are a very important factor to decide the direction of the ocean currents. And because of the rotation of the earth, there is a force which is being created, which is known as Coriolis force. So what do the Coriolis force do? Coriolis force actually deflects the wind. Okay, so rotation is actually from west to east, and then there are some winds which are blowing, which are actually deflected. So they are deflected in this manner. As you can see, this is the direction of the rotation from west to east. Our earth is rotating, and when our earth is rotating, see, the starting of the wind direction is like this. The vertical winds blow like this when they get too much of evaporation, or they get too much of heated on the surface area. They move in a convectional current type, but they are deflected towards east in the northern hemisphere, and they are deflected towards the west in the southern hemisphere because of this Coriolis force. And this force is being created because of the rotation of the earth. So this force is actually also giving the direction. This is also deciding the path of the ocean currents in the factors. Okay, so the path of the ocean currents is also decided by the Coriolis force. So if you see the world map, the ocean currents map, the currents are also deflected and then they reside down, because as they are deflected and they move towards the higher latitudes, they are actually getting cold. And while they are getting cold, they are deciding down towards the equatorial region, completing the circle. And this circle is actually known as gyre or gyre, whatever you can call. Mostly it is called gyre. So this gyre is actually being completed, being given the shape because of the direction of the winds and also because of the Coriolis force. So this is how the ocean currents map look like. Okay. Now here I want to tell you that in the North Atlantic Ocean, this gyre is actually making a sea in the middle of the ocean. So this is a complete ocean which is known by the name of Atlantic Ocean, and because of the movement of the ocean currents in the influence of the Coriolis force and the winds, there is a circular motion created by the ocean currents which actually binds the water on all the sides in between the ocean, and this binded water on all the sides is known as the Sargasso Sea. So this kind of feature is also created by the ocean currents. Next is the topography of the ocean floor, which actually helps in the velocity of the ocean current. So if the volcanic islands, or if structures like this are coming in the way of the ocean currents, obviously they will be having a difference in their velocity. And if structures like this trenches are there near the subsurface area where the ocean is not too much deep, also again the speed, the velocity of the ocean currents will be affected. So topography is also one of the factor where the ocean currents will be changing their direction, or will be changing their speed and velocity. So in nutshell, we saw that the water actually gets expanded and accumulated for about 8 centimeter in the equatorial region, and that is because of the temperature, that is because of the surplus temperature which is we are getting. Then there is another factor of salinity, which is actually defining the density of the sea water or the ocean water. So because of the density, we are seeing the upwelling or the downwelling zones, the accumulation or the residing down of water is seen. So this is how the water is collected. So now this water is getting the direction. This is now the water is getting the direction plus the movement through two things. One is your winds, and these winds are the result of rotation of the earth, which is also bringing the Coriolis force. So winds together with the factors of rotation and Coriolis force is giving the ocean currents direction and also the movement. And that is how the ocean currents are completing gyres, which are the circular motions in the ocean. So the ocean currents here can be divided into some 4 types. Okay, so first type is actually the cold current. So cold current is the ocean current which is actually flowing from polar regions towards the equatorial regions because of the temperature difference. So obviously the water which is far away from the equatorial regions and near to the polar regions will be colder in nature in comparison. And next is the warm current. So warm current is also defined on the basis of direction they move. So whatever equatorial water is moving towards the polar regions, they are known as the warm currents. So they are defined not in the terms of the temperature, but in the terms of the latitude which they are flowing, because there is no temperature which defines the warm or the cold current here. What is defining the warm and the cold temperature is the comparison in the temperature and not the temperature itself. So comparison. Next is the surface current, which is the ocean current which we are talking about. These surface currents are either warm or either cold. And last type is the deep water current, which is the result of downwelling and upwelling, as I explained to you. So these are the factors which create the ocean currents. I hope you have understood why the ocean currents are getting created and how these ocean currents are getting their direction and the movement, why they are getting deflected in a particular region, in the mid latitude region, which is actually the force of westerlies. Again, they are coming down and completing the circle and creating a middle water situation in the middle of the ocean. So this is all about the factors of the ocean currents. In the next lecture, we will be studying about the ocean currents of the world. And the ocean currents in the world, you will be studying three major oceans. The first is your Pacific Ocean, second is the Indian Ocean, and third is the Atlantic Ocean. So in the Indian Ocean, we will be seeing the ocean currents changing their direction. So these are the only ocean currents which change their direction because they come under the influence of monsoon, and monsoon is a seasonal wind but not permanent wind. Seasonal because they change their direction according to the seasons. Okay, thank you so much and take care.